Okay, today is solving square root and other radical equations. A radical equation is one where you have a variable in the radicand or with a rational exponent. So you have a square root or a cube root or a fourth root where the variable is inside the roots. If you have a square root of 2 as part of the problem, but you don't have a variable inside the square root, it's not a radical equation. It's only a radical equation if the variable is within the radical. Okay. Square root is particularly one with a radical of 2. Those are mostly what we deal with, but we will do cube roots and stuff as well, but they won't be that complicated. Extraneous solutions. And we've talked about extraneous solutions before. We don't get them very often. This is one where you get them often. Solutions you get when solving that don't actually work in the original problem. You do everything correct algebraically when solving it. Every step you do with work is just fine. You don't make any mistakes doing the work. You get to your final answer, and your final answer does not work in the original problem. That's called an extraneous solution. You mathematically did everything correct, but your final answer does not work in the original problem, and it has to be in the original problem. That happens often. It happens most often with radical equations like we're dealing with today, and rational equations, which we'll deal with in chapter, I believe it's chapter 9, where you have variables in your denominators. And you will often solve a problem and get a number that will give you a 0 in your denominator. What you do is just throw that answer out. That one's no good. If you have more than one, you might have one that's good, you might have one that's bad, you might have none that work. It's entirely possible there is no solution because none of the answers you got work. Could be that every answer you get works. You don't know. You absolutely have to check. This is one of the ones where you absolutely have to check every answer. And you don't have to do it in great detail, but you just have to at least plug it in and see if it's going to work every single time. Now, we only have one topic today. I am going to do several examples, and then you are going to work several problems. It's the only thing we're doing, okay? So the first one, solve and check for extraneous solutions. Square root of 2x plus 1 equals negative 3. So the first thing we need to do is I need to get rid of my radical. If I have my radical by itself, I want to get rid of the radical, so I need to do the inverse. When we solved problems like x plus 2 equals 3, what did? We subtracted 2 from both sides. We did the inverse function. That's how you solve basically everything, is you do the inverse to what you want to get the variable by itself. So I want to solve 2x plus 1, square root of 2x plus 1 equals negative 3. I need to get rid of the square root. You do that by squaring. The inverse of square root is squaring. And whatever you do to one side, you need to do to the other side. Okay. I square my square root. I just get what's underneath on the one side. Square negative 3, I get 9. Subtract 1, 2x equals 8, divide by 2, x equals 4. There's my answer. Now I have to check it in the original problem, and you can, as far as I'm concerned, you just do it like I'm doing here. Do it mentally. Take 4, plug it in. 4 times 2 is 8. 8 plus 1 is 9. Square root of 9 is 3, not negative 3. It's 3. We have no solution on this one because our answer does not work in the original problem. Now, if you understand what's going on, you can look at the original problem and say, ain't nothing going to work. Why isn't it going to work? Because I have the square root equal to a negative 3. Now, when we solve using square roots, i.e. x squared equals 9, take the square root of both sides, you had to include plus or minus the answer. You don't hear. It can get confusing. I understand that. Because I know some of you think, but the square root of 9 is 3 and negative 3. It is if we're using it to solve the problem. If we're doing it to check the problem, it's not. We always treat it as positive. Yes, it does get confusing. I understand that. Okay, next problem. Very similar problem. But I have to get the square root by itself first. I can't square both sides. If I square both sides now, I will still have a square root. Because I'll have 6 plus 4 root x times 6 plus 4 root x, and I will still have a root x as part of my problem. What I need to do first is I need to get the square root by itself. So what I do is subtract 6 from both sides. And I get 4 root x equals -2. And I know right now I'm done. I have no solution because 4 times a positive value of the square root cannot be negative. Still want to continue on, just to make sure we know what we're doing. Divide both sides by 4. Square root of x equals -1/2 because you always reduce. And once again, I know I'm done. Because I can't square root of x. The square root is going to be a positive value for what we're doing our purposes here. But in order to make sure you understand the process of what you're doing, in order to solve this, take the next step to get x by itself, I square both sides. And I get x equals 1/4. 1/2 squared is 1/4.
Dude,
Okay.
when you square a fraction, that's insane. Because if you square 1 by itself, it's just itself. So less than 1 would have to go less than it. So it makes a smaller fraction.
Yes.
Holy crap. I always knew that was the rule, but if you really think about it, that's why.
So I take 1/4 and I plug it in here. Square root of 1/4 is 1/2. 1/2 times 4 is 2. 2 plus 6 is 8, not 4. Doesn't work. Once again, no solution. That's not going to happen every time, so get used to it. Okay. So the square root of x plus 5 equals 8. I have the square root by itself, so my first step is to square both sides. And I get x plus 5 equals 64. Subtract 5 from both sides, x equals 59. And then I want to check that answer. So I take 59, plug it in for x. 59 plus 4 is plus 5. 59 plus 4 is 64. Square root of 64 is 8. That one's good. Okay, so that one works. Cube root of x plus 4 equals 2. Cube roots can equal negative numbers. Just because you get a negative in there doesn't mean it doesn't work. However, we still want to check. So I have a cube root. I'm not going to square both sides. I'm going to cube both sides. Whatever the radical is, I have to do the inverse. So I cube both sides. The cube root cubed is just what's underneath the cube root. 2 cubed is 8. Subtract 4 from both sides. X equals 4. And then I want to try it. 4 plus 4 is 8. Cube root of 8 is 2. We're good on that one. So far, not that difficult, right? These really aren't difficult problems. You just have to watch your negatives and positives. Next one here, I have to get the square root by itself first. I have something other than the square root on one side. I need to divide both sides by 3 first. I can technically square this one because it's multiplication, but it's just easier if you just get the square root by itself first. So I have the square root of 2x plus 1 equals 2. 6 divided by 3 is 2. Yes?
If you were to square it
first, you'd have 9 on this side. 9 times 2x plus 1 equals 36. Okay. You'd still have to divide by 9 and then go from there, or distribute and go from there. It would work. If it's addition, if it's the square root plus or minus something, you absolutely need to subtract or add first. If it's multiplication division, you technically don't, but I would still do it every time anyways, just to keep it the same for every time. Okay. Now I get to here, square both sides. 2x plus 1 equals 4. Subtract 1. 2x equals 3. Divide by 2. And I get x equals 3/2. And I do leave it as an improper fraction. The only time we use mixed numbers is in answering word problems. Otherwise, you leave it as an improper fraction, but reduce if you can. 3/2, plug it into the original problem. 3/2 times 2 is 3. 3 plus 1 is 4. Square root of 4 is 2. 2 times 3 is 6. That one's good. Next one. I have square root on one side, square root on the other side. Square both sides. 7x minus 6 equals 5x plus 2. Pretty easy to do. Solve for x. Subtract 5x. 2x minus 6 equals 2. Add 6. 2x equals 8. Divide by 2. X equals 4. And then I once again try that in the original problem. 4 times 7 is 28. 28 minus 6 is 22. So I have the square root of 22 on one side. Put in 4 in there. 4 times 5 is 20 plus 2. I have the square root of 22 on the other side. Is that a true statement?
Yeah.
Yeah, I don't need to take the square roots to figure out if I have a true statement or not. I know I have the square root of 22 equal to the square root of 22. It works. It's good. Okay, as it should. Okay. Questions? Okay, a couple more examples. And these are where it gets more complicated. So the first one, I have to get the square root by itself first. So what I need to do first is subtract 4 from both sides. So I get x minus 4 equals the square root of 2x. Square root by itself, everything else on the other side. Square both sides. Notice I have x minus 4 in parentheses being squared. It's not x squared minus 4 squared. It's x minus 4 quantity squared. So you're going to have to FOIL it out. And you'll get x squared minus 8x plus 16 equals 2x. And you have a quadratic you have to solve. First step in solving a quadratic, set it equal to 0. So I subtract 2x from both sides. And I get x squared minus 10x plus 16 equals nada. Two numbers that multiply to give me positive 16 that add to give me negative 10. So this is positive, so they're both going to be negative. 2 and 8. 2 times 8 is 16. 2 plus 8 is 10. So I get x minus 2, x minus 8 is equal to 0. X minus 2 equals 0. X minus 8 equals 0. So I get x equals, I got enough room here. X equals 2. X equals 8. Two answers, and I need to check them both. So in the original problem, I plug in 2. 2 times 2 is 4. Square root of 4 is 2. 4 plus 2 is 6. Does not equal 2. 2 does not equal 4 plus 2. Doesn't work. That one's no bueno. So I toss out that one. I try 8. 2 times 8 is 16. Square root of 16 is 4. 4 plus 4 is 8. I get 8 over here, 8 over there. That one's good. I got one that works. I got one that doesn't. That often happens, but not always. That often is what happens when you end up with a quadratic as part of what you're doing. You get 2 answers. Often one of them is no good, the other one is. Most of the time, that's what works. However, you always need to check both answers. Do not make the assumption because one works, the other one doesn't, or vice versa. Could be they're both good, could be they're both bad. You cannot assume that because one works, the other one doesn't, and vice versa. You must check both answers. Okay. Next one, same thing. I need to get the square root by itself first. So my first step is actually to add 5 to both sides. And I get the square root of x plus 7 is equal to x plus 5. And then from here, I square both sides. Square the square root. I square the x plus 5. The square root portion becomes x plus 7. X plus 5 squared is x squared plus 10x plus 25. And if you take x plus 5 and FOIL it out, get your middle term, combine up like terms, that's what you'll get. There is a shortcut. I am using the shortcut. Your shortcut is square the first term. Multiply the 2 and double it. Square the last term. That's what I did over here. Square the first term. Multiply the 2 and double it. Square the last term. Okay, but if you do x plus 5 times x plus 5, you'll get the same thing. Once again, I have a quadratic. How do you solve a quadratic? Set it equal to 0. Subtract x and subtract 7 from both sides. 0 equals x squared plus 9x plus 18. Yeah. 2 numbers that multiply to give me 18 that add to give me 9. Two numbers that multiply to give me 18 that add to give me 9. What are my factors of 18? 6 and 3, that's what I mean. Remember, you can always set this up. Do the same thing. You can always use that. I don't care. It's not going to do every single step every single time. But you can always set that up if you need to. So x plus 6 equals 3 equals 0. X plus 3 equals 0. X equals negative 3. X equals negative 6. Now, ooh, they're both negative. It isn't going to work. Not necessarily. And you look at this and go, well, they're equal to a negative on the other side. Well, that doesn't necessarily mean they're not going to work. I try negative 6 in here. Negative 6 plus 7 is 1. The square root of 1 is 1. 1 minus 5 is negative 4, not negative 6. That one does not work. Try negative 3 in there. Negative 3 plus 7 is 4. Square root of 4 is 2. 2 minus 5 is, look, negative 3. It does work. Okay. Once again, do not make the assumption that because you have a quadratic and you've got 2 answers like this, that one's going to work and one isn't going to work. It's often that way. Most often it's that way, but it's not guaranteed to be that way. You must always check all your answers. Your turn. Do those. Okay, so let's go ahead and finish these up. First one, you already have the square root by itself. So all you do is you square, but you start by squaring both sides. 2d minus 5 equals 49. Add 5. 2d equals 54. Divide by 2, d equals 27. And then you try it. 2 times 27 is 54. 54 minus 5 is 49. Square root of 49 is 7. That one works. Next one, my first step is to subtract 2 from both sides. So I get the square root of 4c plus 3 equals 3. Then I square both sides. And I get 4c plus 3 equals 9. Subtract 3. 4c equals 6. Divide by 4. C equals 3 halves. Plug that in. 4 times 3 halves is 6. 6 plus 3 is 9. Square root of 9 is 3. And 3 plus 2 is 5. That one works. And then I try the next one. It's a cube root, so I have to cube both sides. Cube both sides. 2m minus 4 is equal to 27. Yeah, 3 cubes, 27. Add 4 to both sides. 2m equals 31. Divide by 2. M equals 31 halves. And then you try it in there. 31 over 2 times 2 is 31. 31 minus 4 is 27. Cube root of 27 is 3. This one also works. Questions on the first 3 problems? They're fairly straightforward, not too much of an issue with any of those. Okay, next one. Same process. Square root equals square root. I don't have anything else involved. Square both sides. 5y plus 5 equals 7y minus 1. Subtract 5y from both sides. 5 equals 2y minus 1. Add 1. 6 equals 2y. Divide by 2. Y is equal to 3. Plug it in. 3 times 15. 3 times 5 is 15. 15 plus 5 is 20. Square root of 20 over here. 7 times 3 is 21. Minus 1 is 20. Square root of 20 equals the square root of 20. This one works. Be careful. The most common one where it doesn't work is where I have a negative here and a negative here underneath the square root. We're not allowed to have the square roots of negatives. I know we used I for that. Still, it shouldn't be that way. It's the only time it really doesn't work. Next one, this is the most complicated problem. Subtract 6 from both sides. I get the square root of x equals x minus 6. Square both sides. Square. Square, I get x equals x squared minus 12x plus 36. Subtract x from both sides. 0 equals x squared minus 13x plus 36. Set it up, negative 36, negative 13. Two numbers that multiply to give me 36 that add to give me negative 13. Negative 4, negative 9. Right? Yeah. So I get 0 equals x minus 4, x minus 9, x minus 4 equals 0, x minus 9 equals 0. X equals 4, x equals 9, and then I have to try them. Square root of 4 is 2, 2 plus 6 is 8. 8 does not equal 4. That one doesn't work. Try 9. Square root of 9 is 3. 3 plus 6 is 9. This one does work. Like I said, 90% of the time, you have two answers. One works, one doesn't. Do not always count on that, though. Okay. And I do believe that's it.